topic is dynamic equilibrium and its graphical representation. In our previous lecture, we have learned that what does mean by dynamic equilibrium and what is the relationship between dynamic equilibrium and a reversible reaction. And now we have the topic that is dynamic equilibrium and its graphical representation. Now we will represent it with the graph. So let's start. For example, if we have a reversible reaction, we have a reversible reaction. In a reversible reaction, we have seen that we can gain the dynamic equilibrium. We can gain the dynamic equilibrium. Now, these are the two terms that you have learned already, but I'm going to review over this reversible reaction in which the reactants changes into the products and the products can be again going to recombine and changes into the reactants. So this is the reversible reaction. But when these two processes of changing of reactants to the products and products back into the reactants become equal to each other, that state of the reaction is known as the dynamic equilibrium. As in our previous lesson, we have a look on that when a liquid changes into vapors phase or the gas phase. So liquid changes into vapors and vapors again recombine or unite and changes into the liquid. So this process is vaporization, and the second in which the vapors changes into the liquid, this process is known as condensation. So these two rates become equal to each other. This state is known as dynamic equilibrium. So for the dynamic equilibrium, let's have a simple example. To represent it graphically, we have two reactants, the reactant A and B, the gas phase. So these two reactants combined and forming the C plus D products. Here A plus B are the reactants and C plus D are the products. This is the forward reaction, and this we have reverse reaction. Forward and reverse reaction. So we will gain the equilibrium state when the rate of change of A plus B to C plus D becomes equal to the C plus D again changes into A plus B. So we have shown it with the double arrow because this is a reversible process. Reversible process. So what does the graph is going to tell us about that? We have to draw a graph in which along y-axis we have to take the rate of change and along x-axis we have to take the time t. In the start we have see that when A plus B started to react, the concentration of A plus B reactant is more and C plus D is less. At start we have see that the concentration of A and B is more and concentration of C plus D is less. But so the forward reaction, its rate, the rate of forward reaction is also high. So these two things are high at the start, rate of forward reaction and the concentration of A plus B, and the concentration of C plus D is low. But after some time, we have see that the forward reaction is going downward like this, and the reverse reaction as at the starting its rate was 0, but after some time it started to increase, and a time come when their rate of these two reactions becomes equal. The rate of forward reaction becomes equal to the rate of reverse reaction. This state is known as the chemical, or we can say that dynamic equilibrium state. So before the gain of the chemical equilibrium state, we have seen that the concentration of A and B is going to low down, concentration of C plus D is going to increase, and the rate of forward reaction it becomes down, and the rate of reverse reaction is going to increase. And a time comes when the rate of these two reactions becomes equal to each other. That state is known as equilibrium state is reached when both the rates become equal. Which one rate? The rate of forward reaction and the rate of reverse reaction. With the passage of time, we have seen that these two rates becomes equal to each other. And if the 10 reactants are going to change into the 10 products, then the products are again changing into the reactants. That state is known as the chemical equilibrium state. And this is a simple graph that is going to show the rate of graphical representation of the dynamic equilibrium. Next, let's have an example from the chemical reaction. Simple, we have a chemical reaction like hydrogen iodide H2 plus I2 are going to combine and changes into the hydrogen iodide. So this is the simple example. Now hydrogen iodine and hydrogen iodide are in the gas phase. If we are going to draw a graph, let's have a look. For example, we have x-axis and y-axis. So we have time along x-axis and we have rate of reaction along y-axis. So at the start, we have the rate of forward reaction is high and the rate of reverse reaction is low. So as the time passes, the rate of forward reaction started to slow down and it becomes a steep line. Next, we have the rate of forward reaction it started to increase, and we have a time when the rate of these two reactions becomes equal to each other. So this is the forward reaction. Forward reaction is this in which hydrogen plus iodine are going to combine, and these are the reactants. And the rate of reverse reaction in which we have hydrogen iodine, and this is the reverse reaction and these are the products. This is the place where we have reached the chemical equilibrium state. So this is the chemical equilibrium, or we can say that the dynamic equilibrium state. So here we have forward reaction and reverse reaction. So a time comes when their reaction rate becomes equal to each other. The rate of forward reaction, rate of forward reaction is equal to rate of reverse reaction becomes equal to each other. So this is the chemical equilibrium state, or we can say that it is the dynamic equilibrium state. So this is a simple graphical representation of the dynamic equilibrium. I hope you guys understand about this. If you have any queries, you can ask me about that in the comment section. For that time, have a good day and Allah Hafiz.